Recording in progress.
You guys quiet, please. So just to show you how these factoring problems work, whenever you have four terms, there's something called factor by grouping. What you do is you group the first two and last two terms. And within each group, you pull a common factor. The common factor for the first group is x squared, leaving behind x minus 5. And the goal is that you get the same group in the second set of factoring. So negative x plus 5, I can factor out negative 1 and also get x plus 5. So it happens I have x squared minus 1 and x minus 5. And now it's not quite factored all the way because x squared minus 1 can be broken down a bit further, like that. And now I have it the way I want it, right? All's good. Let's look at number 2. For number 2, just treat it like a quadratic, like you usually do. So 2 numbers that multiply negative 15 and add up to negative 2, that'd be negative 5 and 3. But instead of saying x minus 5 and x minus and x plus 3, we're going to do x squared minus 5 and x squared plus 3. And that's the best I can do because 5 is not a perfect square. And I'm going to do the same thing for 14. X squared minus 8 minus 5. That's with negative 13 in the middle, 40 at the end. Factor by grouping over here again. I can factor on x4, x squared plus 2. Factor out negative 16, x squared plus 2. x4 minus 16, x squared plus 2. And x squared minus 14 can be broken down even further as x squared minus 4 and x squared plus 4. And that can be even broken further as x minus 2, x plus 2. X squared plus 4, forget about it. That's just, it is what it is. And of course, you have x squared plus 2. And let me save that as a screenshot. There we go. And then we got 4 more here. I can factor on x squared, x4 minus 4. That can be broken down further as x squared minus 2, x squared plus 2. Keep going. Just going to do this by trial and error. 2x squared, x squared, I think plus 2 minus 3. That's as far as I can go. Factor by grouping again. Come on, here we go. Factor on x squared, x or x minus 1. Factor on negative 1, 4x minus 1. X squared minus 1, 4x minus 1, x minus 1, x plus 1. And then here, that's x squared minus 9, x squared minus 1. Break it down even more, x minus 3, x plus 3, x plus 1, x minus 1. Okay, a lot of factoring practice. I'll put these answers in schools. This is being recorded as well. So you can watch this recording when you get a chance. Do submit the homework when you have an opportunity to do so you can get credit for it. Any questions on these at all? No? All right. Then the CPM problems. Let me just pull up the answers so you guys can see how those answers look. I do need to make screenshots of them, upload them to schools when I get a chance. Maybe tomorrow I'll have more of an opportunity to do that. I know we have SJTI tomorrow. Yeah, I know. Does anyone know the schedule for SJTI? Like, what time do they have to be here? What time do they have to be here tomorrow? No, I know that, but usually we all meet department first, no? It's normal, okay. And what time we finish? Okay. That's nice. Okay. I can live with that. Okay. All right, let me pull up CPM, guys. 835 through 840. Let's go through the answers. Oh, you ready for the next part? Right. No, you can't, but you don't need it. So. All right. Okay, let me show you the answer for 835 through 840. CPM. Here we go. What's going on? Okay. I'll pass them out when I'm ready to do the lesson. Okay, for 835, you're asked to graph these or do a rough sketch. So what you want to do is look for the x-intercepts. For A, the x-intercepts are 0, -1, and 3. See how it crosses there? And given the end behavior of it, there's a negative out in front, and the highest term is x cubed. So it's got to go left. The left arrow is pointing up, the right arrow is pointing down. For B, you have an even degree. The leading term is x4. So both arrows point up is positive and even degree. Across the x-axis at 1, -2, and 4. And for C, degree is 4. Both arrows are pointing up. X-intercept of -2 and 4. It's going to look a little flat at -2 because that's a higher exponent. But if it's even, it bounces. We talked about that as well. For 36, where's that cross the x-axis? Plug in 0 for y and solve for x. Not that hard. It's going to be a radical. I think it's -3 plus or minus √5, if I'm not mistaken. Yeah, -3 plus or minus √5. For 37, at 74, 0, we call that a double root. But -29 crosses. So it bounces at 74, crosses at -29. For 38, ask for possible answers for the if you have these x-intercepts. So obviously you need x plus 3 and x minus 2. You need x plus 3 and x minus half or 2x minus 1. FOIL, you get all that jazz there. For 39, the degree, highest exponent is 2 for A, 5 for B, 3 for C, and 6 for D. Yep. For 40, consider the polynomial graphs which define polynomials. Parabolas, cubics, lines are all polynomial functions because they have x raised to some power. The exponentials is something raised to the x power, or circles have x and y squared. That doesn't count. Plus, not a function for E. So it's A, C, D for that one. Those are your polynomial functions there. And then we have 42 and 43 really quickly. 42 is writing the equation of a circle. Circle is center of the line y equals 3x in the first quadrant is tangent to the y-axis. If the radius is 2, what is the equation of the circle? Ooh, that's kind of tricky. With the center on the the center's on that line. Got it. And the equation itself is tangent to the y-axis. Got it. Okay, so then what's happening? It's still a little tricky. What's happening here is that you have a y equals 3x, which looks like this. And tangent to the y-axis radius is 2. So you have 4 on this side. X minus h squared plus y minus k squared. So let me think here. I don't know. 2 and 6. I guess you need. That's interesting. Oh, I see. Okay, you gotta be 2 away from the y-axis, and then the y coordinates triple that. Got it. And for B, I guess your radius is 3, so you got to be 3 away. Got it. Okay, that's just a little tricky. I'm not sure. Well, I don't think we'll ask on a test. That seems kind of weird to me. And then 43, just do the sketches. You've done exponential functions in the past. 2 to the x, you know how it looks. The x plus 5, just shift up 5. Not hard at all. I know you guys can do that one, so I'm not worried there. And it looks like they had a part C, but we didn't have part C there. So, okay, cool. I think we're all set. Perfect. Okay. So, yeah. Let's go ahead and move on to the notes. So close. And some of you guys need copies of notes. Who needs copies of notes? Okay, no problem. These are just for today. Otherwise, the rest of you guys should have notes out. Okay, so notes are very short. Then we will go outside, and that also helps you guys beat the lunch rush. Yeah, so we should be fine. Yeah, I only need about 10 minutes, like 10, 12 minutes for the notes, and then we'll have about a half hour outside. Should be good. And it's, yeah, I apologize for lingering with all this like stuff I had to do with our class. Anyway, so for 8.1.13, how can I find the equation? So this is just more like looking at the graphs and trying to figure out the equation from the graph. That's what this exercise is all about. And the homework is just gonna be CPM stuff. And I actually printed the CPM stuff too. So I'll give that to you guys when I finish the notes today. So let's just get right to it. So 846. What's the difference between the graphs of that function and the other function? They're pretty much the same thing, right? Like the x-intercepts are actually the same, right? Let's like if we have x minus 3, what's the x-intercept we have x minus 3? And x plus 1 is -1, and x squared is 0. The only difference is the 3 there. So what's going to happen is that the leading coefficient of the second equation is 3, but it's 1 for the first equation. That means that the second equation's graph will be a bit more steep than the graph of the first equation. That's all that really tells us. That's it. So we can do this without using a graph calculator or Desmos. Just think about it, right? They're pretty much the same thing. The only difference is the leading coefficient, right? Because they do have the same x-intercepts, same y-intercept also, and same end behavior. The end behavior is the arrows. Because your degree here is 3 for both. No, 4. So arrows look like that. Okay. Guess me on 847. Are the intercepts enough to? So Melvin wrote the following equation to represent the graph of the right. It's going to decide how well the graph represents how well the equation represents the graph. What can you do to equation make it a better fit for the graph? Will the equation fit better? Okay, well, the x-intercepts are definitely -3, -1, and 2. Definitely, 100%. The end behavior is also correct too, because your degree is 4. I would look at the y-intercept. Is the y-intercept done correctly? I don't know. Let's find out. What's the y-intercept here, guys? If we work it all out. 3 times 1 times what? No. 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 4, thank you. So it's 12. The last part's supposed to be 4, and then we multiply 3 to get 12. So the y-intercept's too high. So I'd probably make my graph look kind of like this. So you got to adjust the y-intercept. So how would you make it better? Adjust the y-intercept. That's what I do. Okay, let's look at part B. Before I figured out, you could have written the polynomial for this graph as the following. What if you did not have a graph in calculator, but you were told that the graph goes through the point 116? How can you use that information to determine the exact equation? So here's what you do. You would say y equals, well, it's already written there, but I don't know why I'm rewriting it. You say 16 equals a, 1 plus 3, 1 plus 1, and 1 minus 2 squared, which should get us 6a, I think. No, 8a. 8a? So a is 2. Yeah, there you go. All's good. Yep. All right. So halfway through the notes. Hopefully we'll be done by 12. All right. So here, now that you have more expertise upon equations and their graphs, the Math America Land Carnival Company has hired your team to find the exact equation represents roller coaster track. The numbers along the x-axis are hundreds of feet. Okay. So like 1 and 2 and 3 are like 100 feet, 200 feet, 300 feet. The track will be 20 feet below the surface. So it looks like the y values go in intervals of 10, I think, or I don't know. But this gives us a point 2.5 comma -2. -0.2, sorry. Okay, fine. What degree polynomial represents the portion of the roller coaster represented by the graph? Okay, well, how many x-intercepts do you guys see? 1, 2, 3. But there's a bounce. So it's actually going to be degree 4. You can write it like this: y equals a x minus 2 squared and x minus 3. So degree is 4. The roots are 0, 2, and 3. Find exact equation. So for part C, I'm going to plug in this point as well. If I solve for A, I'm going to get a calculator. So very important that you have to use a given point to solve for the leading coefficient, or A, right? Times 0.5 squared times -0.5. I think I'm doing this correctly. -0.2 divided by that number. I get 0.64 for A. So that's my equation. And what is the deepest point of the roller coaster's tunnel? I guess I'd have to graph that. That's hard to tell. I don't know. So now I'm gonna go to Desmos. So that's a Desmos thing. Find the min. Totally a Desmos thing. Yeah, it looks like the lowest point is 0.557 -1.813, but we have to scale it correctly. So what was the deepest point? We'll just give the coordinates. It's fine. What was it again? It was I already forgot. 0.557 -1.813. Cool. And then lastly, for 849, some polynomials have a stretch factor just like the A and parabolas. Another parent function, find an exact equation. You include stretch factor for each graph below. Okay. So in this case, what are the x-intercepts here, guys?
1 and -2. Oh, it's hard to start.
I think 2 and -2.
Yeah, it's one. Yeah, 2 -2. I was talking about B.
Yeah, for B, it would be -1 and 2.
-2 and 1.
No, it's -1 and 2 for B. Right? And the y-intercept here is 0, 15. The y-intercept here is 0, -3. What was that? Sorry? 16, thank you. Okay, now at -2, you got to bounce. And here, both of these bounce. Well, yeah, of course. That's when we say bounce, it's off the x-axis. So in this case, it's y equals a x plus 2 squared and x minus 2. And here, it's y equals a x plus 1 squared x minus 2 squared. So I plug in 16 for y and 0 for x. A is -2. Here, plug in -3 for y and 0 for x. A is going to be -3/4. And in here, you have that. So that's how you do those problems. So that's what's happening here now. Now we're actually writing equations from graphs. I actually love these problems. These are one of my favorite problems. This is definitely a test problem, just so you know. Definitely this is a test problem. So yeah, that's that. Homework, can you pass it out? Homework. It was so long. And if you want to grab yourself, we'll go outside. That's doing a status plot. For the senior lost their patio privileges.
For what? For what?
The senior patio, they lost their privileges for today.
Why?
So they asked all the teachers to sit there, have lunch today. Because they didn't respect the space or made it messy. Yeah. I think that's why. And just stay, you guys don't want to stay, stay kind of close by buildings. Yeah. Oh, don't stop this as well.